Hi, algebra class. Here is your lesson on substitution. Here's my dog. Say hi to my dog. Say hi to Kratos. Kratos, say hi. All right. So he doesn't want to do algebra anymore, thank goodness. So here's our first example of using substitution to solve the system of equations. Now, remember in class we talked about remember in class we talked about how we use substitution and system of equations. And here you'll see that y equals 4x plus 11. So they're saying that y actually equals 4x plus 11. And you'll notice down here that they substituted it in the first equation where they saw y. So pay attention to that. When you do this, you want to make sure that you actually substitute it literally for what they want you to substitute it for. So now in this case, they are distributing the negative to the 4x and the negative to the 11. So after you distribute and combine the like terms, 3x minus 4x is equal to negative x, and you're left with negative x minus 11 equals negative 7. And then, of course, add 11 to both sides. Let's go ahead and get rid of these red lines. Add 11 to both sides, and you get negative x equals 4. Of course, you can't have a negative x, so you multiply both sides in essence by negative 1, or you just take the negative from here and put it over here on the other side, so x is equal to negative 4. After you've actually done your substitution, then you're going to replace what your x equals for negative 4 into either equation. Let's pick the second one. That's my dog again. And y equals 4 times negative 4, which is negative 16. Negative 16 plus 11 is negative 5. So your ordered pairs are negative 4 and negative 5. All right, we're going to take another look at another example where there can be an infinite number of solutions. If you graph this ordered pair, like you all have been taught to do, that would be your check. Of course, the graph looks like, and you all know how to graph, your graph would also show that negative 4 and negative 5 is your ordered pair where x marks the spots. And of course, you have to know what your y-intercept is and what your slope is, which you all know how to do. Everything should be in slope-intercept form. So let's take a look at another example. So this example shows your y equals, the substitution you're going to use is negative 2x minus 4. And of course, notice it down here where they see the y, that's where they're substituting. So your new equation is, after you substituted it, is 4x plus 2 times negative 2x minus 4, close parentheses, equals negative 8. Now remember, after you've done your substitution, now of course you have to distribute. So you're going to use the distributive property. You're going to distribute the 2 to the negative 2x and the 2 to the negative 4. So you're going to use the distributive property to do that. And then eventually you'll combine the like terms. So keep your 4x that you started with, and then 2 times negative 2x is negative 4x. 2 times negative 4 is negative 8. And notice, I want you guys to notice that your positive 4x and your negative 4x have just eliminated each other. So now you don't even have an x equals anything. You know that you're only left with this original equation, and knowing what you know about linear equations, this is a true statement. Negative 8 does equal negative 8. So this equation is really exactly the same as that one, and I'm going to prove this because I'm going to put this standard form equation into slope intercept form. So in order to do that, we have to get your y by itself, and we're going to subtract the 4x from both sides, which, if you notice, that's what they did here. They subtracted the 4x from both sides, and we're left with 2y on this side. So whatever I do to the left, I have to do to the right. So I have to subtract 4x on this side as well. So sorry about the slowness. I have to use the mouse to do it. So here's my equation. And it shouldn't be a plus, it should be a minus. Let me go ahead and erase that. Go ahead and erase my plus sign. Let's give it a, because it's a negative 8. All right, so I'm left with 2y. I have to divide both sides by 2. So I'm going to divide all of this by 2. And now I'm left with y equals, and you'll notice, you should notice, that we're left with negative 4 divided by 2 is 2. And negative 8 divided by 2 is negative 4. So if I put this equation in slope-intercept form, they are exactly the same equation. And you would get the same answer if you use substitution, because right here, the x's were eliminated. So you're just left with your constants, which are equal terms. If you look at how you check this, or if you graph this, you can definitely, you know that both of these are the same line, and there are an infinite number of solutions. Let's go ahead and take a look at one more equation that's in a word problem. All right, in this equation, we're going to talk about tree preservation. A town ordinance defines an adult tree as having a diameter greater than 10 inches and a sapling as having a diameter that is less than 10 inches. So if you think about this, remember what we know about diameter, it's circular. So let's imagine that an adult tree has a diameter of about 6 inches or 10 inches. That's what this looks like. So a sapling, which is a baby tree, is less than 10 inches. So the ordinance requires that on a new building project, 2 new trees are planted for each adult tree felled. That means an adult tree, if you chopped it down, you have to plant 2 new trees. And 6 new trees are planted for each sapling felled. So you have to plant 6 trees if you cut down or if you tear down a baby tree. Last year, there were 167 trees felled, and the community planted 742 replacement trees. How many of each type of tree were felled? So they want to know how many adult trees were cut down and how many baby trees were cut down. So we're going to take a look at this video, quick video, where they're planting a new tree in the place of a felled tree. Isn't that nice? It's going to grow up big and strong now. So let's take a look at what our equations would be. So A is going to be adult trees, that could be X, and T could be sapling trees, so that could be Y. Now remember, you can use any variables you want, but A is like X and T is like Y. So just remember that. They're just unknowns and they can be any letter. So what they've told you is that adult trees and sapling trees that were felled, that were cut, equaled 167. So there's one of your equations. And then they have also told you some other things. They said that you have to plant 2 trees for every adult tree that felled. So you know the 2 goes with the A. And 6 will go with the T, because you know that you have to plant 6 trees for every sapling that is cut down. And in total, the replacement trees were 742. So your second equation is 2a plus 6t equals 742. Both of these are your equations. And whenever you do word problems, you have to decipher what information you know. And we know that we have adult trees and saplings together were 167 that were cut down. We also know that you had to plant 2 for every adult that you cut down and 6 for every baby tree that you cut down. And what they did was they replaced them with 742 trees total. So hopefully that makes sense. So this equation represents the total of adults and trees felled, saplings felled, and this represents how they were replaced. And you got all of that information from your word problem above. So the first equation can easily be solved for A or T, and the second method, then you can select a method to solve how you want to do it. So do you want to solve for A or do you want to solve for T? I'm going to go ahead and solve for A. We're going to go ahead and solve for A. So we're going to do method 1. We're going to solve for the first equation. So of course you have to subtract T from both sides. And now we know that A equals this. So we're going to use 167 minus T in our other equation. We're going to substitute. We're going to substitute 167 minus T for A because it said A equals that, which you notice that they did here in the second equation. Okay? Distribute 2 times 167, which is 334. 2 times T, which is negative 2T. Keep your 6T, that stays the same. Keep your 742. 334 stays by itself, but we have to combine our like terms, which is negative 2T and 6T. And we get negative 4, or positive 4, sorry, 4T. And I'm going to go ahead and put this in. You don't have to necessarily switch this around, but you do have to know that we need to subtract 334 from each side. All right, here's my other dog. Say hi to Ticket. Say hi, Ticket. Hi, Ticket. There's my other puppy. Okay. She thinks she's going to learn algebra. All right, so I'm going to subtract 334 from each side. So now my 4T is by itself. And 742 minus 334 is 408. Now, of course, I divide each side by 4 because I want to isolate the T. And I know that there were 102 saplings of the 742 that were replaced. So now all I need to do is determine how many adults there were. And you can do that really simply by taking 742 and subtracting 102 to get your answer. Let's go ahead and see how they did it. That is how they did it. Well, no, that isn't how they did it. They substituted 102 in the original equation and then subtracted 102 from 167. Yes, that would be correct because you want to know originally how many saplings and how many adult trees you had. Well, we know we had 102 saplings that were felled, and we know that we also had 65. Those two together equal 167. Now you can do the same thing if you decided to solve for T. The only thing is that now you would substitute it right here, and you would substitute it with 167 minus A. So you would do the exact same thing that we just did with A equals as T equals, except now you would put it here, and you're going to get exactly the same answer. If you want to try it, you can. That is how you do it. I'm hoping that this review of how we did substitution in class is helpful. You can rewind the video and you can look over it as many times as you want to. Now you're going to do some questions. Mrs. Pagano is going to give you, or she's given you, a sheet of paper. And I'll have this on Google Classroom as well, but it's a study guide that shows you step by step how to do substitution with X and Y, and a simple one, and then a little bit more difficult one. So what I want you to do on the study guide, and you have to have your own Google Doc to do this, or you have to create a Google Doc to do this. I want you to do exercise on page 12. I want you to do number 1. I want you to do number 3. I want you to do number 6. And if you want to challenge yourself, I want you to do number 8. Now, it's up to you if you want to do number 8 or not. Those of you that really get this, I'm going to kind of expect you to do it. But I want you to do number 1, number 3, number 6, and number 8 if you want to overachieve and really practice this. Because number 8's got a little bit of a trick to it. Make sure that you show all of your work and all of your steps, meaning that you need to show all of your work and all of your steps that look a lot like this. You don't necessarily have to do the writing portion, but you do have to have all of this. And it is helpful if you separate your substitution numbers with another color. This will be very helpful. I look forward to seeing your work, to see how you understand this. Make sure you show all of your work. Overachievers are those of you that really get this. I really want you to try 8.